I am a research associate professor. I work for the Center for Environmental Biotechnology and the Department of Microbiology. I've done numerous research projects over the years, but the research project that I've been working with OIT has to do with what's called high-throughput sequencing. The reason I had to start working with OIT is because I am quickly running into the phenomenon called data deluge. And this phenomena is occurring across the world and affects everybody's life in ways that they don't even understand, including all of the large credit card companies have massive databases and they store large amounts of data. A number of your cell phone companies all have large amounts of data storage. So when I began working with this high throughput sequencing, I found that my typical desktop computers, which might store, a few million megabytes, is becoming obsolete, and that I'm now running into having to do manipulations with gigabytes of data and up to terabytes of data. So this has now caused great problems in the sense that I have to be able to move my data across networks. I have to be able to manage and store the data, and I also have to use new and rapidly developing data analysis programs for which are not run on typical platforms such as Windows and Macs, but are rather Linux-based programs. Today, in this research technology that I've been working with OIT deals with DNA sequencing technology. DNA sequences are found in all living things, and they consist of 4 bases that we call A, T, C, and G. So the first DNA sequencing technology was printed out on simple pieces of paper, and when I first got my first sequences back from a company in California, I physically typed each of my 4 base pairs into a word processor and then did the data analysis. Well, DNA sequencing technology has rapidly utilized the computational abilities that have developed in parallel, and from the 1990s into the 2000s, technologies increased rapidly, and DNA sequencing has moved from taking up kilobytes of data space to gigabytes, and now very shortly we're going to be into the terabytes data collection of DNA sequences. Data transfer was one of the first issues that we had to deal with in high-throughput sequencing technology, because our data is generated in Oak Ridge, and then we have to move our data from Oak Ridge over to our computing systems here at University of Tennessee. In the beginning, data transfer was done by me physically taking an external hard drive and taking it out to the machine and downloading the data, and then driving down I-40 back to UT, which is not really a very secure way of transferring data. So in the first years of this process, Stan Pinkleton and John Rose became interested in helping me find ways to electronically transfer the data from Oak Ridge to the University of Tennessee. The process, as I learned, is more complicated than simply clicking a button on your computer, because there's also issues with security and firewalls and making sure that it is efficiently transferred. We're working in the process now of how to transfer larger amounts of data from the gigabytes size to the terabyte size. The first data storage and management issues with the high-throughput sequencing was how to store these megabyte or gigabyte size files long-term. That required us to purchase through separate funds a computing cluster, which is a Linux-based server. This instrument can't be stored in our regular laboratory, so through the help of Stan Pinkleton and John Rose, and also with Darren Zeller, we now have our computer cluster stored in the Stokely management system with the other servers. And Darren Zeller has been very kind to basically babysit my cluster so that I don't have to watch it, and if things go wrong with it, he will let me know and he's also helped me with some of the Linux installation software, which, not being a computer-based person, has been very helpful. In high-throughput sequencing technology, once you have transferred your data and once you have stored it, there's multiple layers of DNA analysis that go from the basic processing of the raw data to DNA sequences that people can visualize, and then additional post-step analysis so that people can interpret what these DNA sequences mean. Because there's multiple components to the data analysis, it becomes complicated, and many different people have written programs, but most of these programs do not run easily on your typical Windows-based operating systems. So you have to then begin to look at running programs on Linux-based systems. And since I am not a computer-based person, transferring from Windows operating system to Linux-based systems is rather technical. So through this process, several people have been very helpful. They include John Rose and his graduate students, who are helping me install programs onto Linux-based systems, which include potentially my own cluster, but also the Newton cluster, which is a high-performance computing system that's been made available to faculty at the University of Tennessee. For us non-computing type of people, the installation of Linux-based programs can be rather difficult, because when they're open source programs, they're usually based on previous existing programs which may not already be on your computer. So the installation takes time, and it's very helpful to have students who are familiar with the requirements of Linux-based systems. Particularly, Bob Minchin is also very interested in these new DNA analysis type of programs, and is offering to help us in the future and people on campus to figure out what type of programs would be best for people to use. So these issues dealing with data transfer, data management and storage, and data analysis cross-cuts many different scientific disciplines. As new faculty arrive at University of Tennessee, it's very likely that they may bring in some new ideas of what's the best ways to manage these problems. I believe that OIT is also very receptive to assisting both new and already existing faculty through their OIT research assistance, and also through storage and web services. I would encourage them to maybe help join us in a campus-wide dialogue on how we're going to move forward in dealing with these types of issues. As University of Tennessee tries to become a top 25 research institution, we really need to have a plan going forward. John Rose did do a survey earlier this year of other top 25 schools, and we find that there is no one way that other universities are addressing these problems. Some universities have taken a very administrative top-down approach, and that they already have in place existing protocols and avenues for the data transfer, managed storage, and data analysis. Other universities have taken more of a center core approach, where they have used a very large amount of money and developed a small infrastructure for that core, not necessarily related to the information technology already existing at that university. I think it is critical that we try to come up with some solutions, and I hope that other faculty and across other sciences will maybe try to join us and help us find some good solutions. At a national level, several funding agencies are now requiring the incorporation of data management plans into their proposals. As a university, this data management plan will become more important in the ability to obtain research funds. So it would be useful as a community if we could come up with some solutions to solve these data management issues.